So here I'm giving you a reaction. I want you to predict which is the base and which is the acid. They ask you to draw molecular models. I'm not going to ask you to draw models on the exam, but the Lewis structures are basically a good representation of what the models would look like anyway. So it's probably a good idea to draw the Lewis structures, because then you can see which electrons are maybe becoming shared and which electrons are not becoming shared. So for 159, if we look at A, we have OH minus. We recognize that as a base, and H3O plus, which is an acid. But if I draw the Lewis structures, I can see more clearly exactly what is happening here. So as we said, an acid is something that has an extra H plus it can give away. Because this oxygen has a formal positive charge, normally we know oxygen is the second most electronegative element. But an oxygen with a positive charge is even more electronegative, because electronegativity is the ability to attract shared electrons. And if it has more positive, an overall positive charge, is going to attract electrons more. So these electrons are very much attracted to the oxygen, pulled away from that hydrogen. That gives the hydrogen a huge quantity of positive charge. There, on the other side, I have a formal negative, because that oxygen has too many electrons. And so that negative is going to attract to this positive and grab it. And so on the product side, I can predict that this is my base. It's the one that a base can accept an H plus, so you really need at least some quantity of negative charge to accept an H plus, because the opposite charges attract. So the base will pick that H plus off of the acid, and I'll make water. So the OH minus will become water, because it will become it had an OH with 3 lone pairs, now sharing one of its lone pairs with another hydrogen. The other molecule lost that hydrogen but kept the electrons. That's what an acid does. And so that also makes the water, because that oxygen now has the 2 bonds to the hydrogens it already had, and the 1 lone pair it already had. But now these electrons that were shared become a lone pair, because they stay behind. If you look at part B, we can do the same type of analysis. Give you an NH4 plus and an NH2 minus. So we can draw Lewis structures for those. A nitrogen with 4 hydrogens. 4 bonds of known lone pairs. When we apply the formal charge formula, we get a +1 formal charge for that. The other nitrogen has only 2 hydrogens and 2 lone pairs to give it enough electrons to give it that full negative. And we're drawing the Lewis structure. We would count 5 valence electrons for the nitrogen, +1 on each hydrogen, +1 because of the negative charge. That would be 8. And so we got to put 8 in there. So now we calculate the formal charge on the nitrogen. We get a -1. Seeing the charges is really helpful, because we can see that this nitrogen here is very electronegative because of the extra positive charge, allowing it to attract electrons closer. The other nitrogen is not very electronegative because it has extra electrons. It's not holding onto its electrons nearly as tightly. So the electrons it has could possibly be shared. So again, I'm going to share these electrons with this hydrogen, and these electrons are going to stay behind with the nitrogen. So in this particular example, the first molecule, instead of NH3, it's now going to be, instead of NH4, it's now going to become NH3, because now it only has 3 hydrogens, and that other pair of electrons it was sharing becomes a lone pair, so now it has no formal charge. And the other molecule had 2 hydrogens, but now it's sharing one of its lone pairs with another one. It still has 1 more lone pair, so that's also an NH3. And so it's very helpful to draw the Lewis structures if you can do that. But even if you don't have the Lewis structures, you can still solve this, because you see something has more positive charge, usually that makes it an acid, right? What an acid does is it donates an H+. So if it already has too much plus, it's easy to donate one of those pluses because then it will become neutral and balanced. So if I have something that has an extra H+, it can donate that. The other one can accept that. So really, if this has 4 hydrogens and it loses 1, and it loses the H+, now it doesn't have any charge, and it only has 3 hydrogens. If this one had 2 hydrogens, and it picks up another H, now we'll have 3, and then the H+, it picks up that plus, balances the negative, then that also has no charge. So you can predict what the products will be once you recognize which is the acid and which is the base, and recognize that the acid is going to donate an H+ to the base. It will have 1 H+ less than what it started with, and the base will have 1 H+ more than what it started with. Yes?